had this warm up to do. So I know yesterday we didn't really get to do the dog activity. We didn't really finish lesson 1, but that's okay because lesson 1, the goals are something that you probably have already been doing, and it was describing and graphing situations. So like a really key skill is looking at a graph or a certain situation and be able to tell me about that situation based on the graph. So here's some graphs of like not actually a situation you saw before. It's from a like little activity about a dog, but here it is. Each graph represents the distance of a dog from a post as a function of time since the dog owner left to purchase something from the store. Distance is measured in feet and time is measured in seconds. You have those graphs on your paper. And you were asked all of these questions about each of the days. So table 1, we'll start with you. How far away was the dog from the post 60 seconds after the owner left? Yes. All right, 4 feet. Class, do you agree with that? So reading a graph is a skill. So here's the time in seconds. If we want to know 16 seconds there, how far away it was, you got to see where it touches on the line that is graphed. So for day 1, it's 4 feet. Table 2, for day 2, how far away was the dog from the post 60 seconds after the owner left? Four feet. All right, class, we agree with that. So now you should be looking at the day 2 graph. 60 seconds is here. Here's where it touches on the line at the 4. So 4 feet is how far it was. Table 3, what about day 3? How far away was the dog from the post 60 seconds after the owner left? 4 feet. So it happened to be the same in all situations. I think that was actually like a stipulation yesterday in the activity that you didn't necessarily get to. I did do the activity previously. If you want to go watch that video from last year, it's just Mondays are hard to get through when it's only like 35 minutes. So I'm not super concerned about it. We use this skill all the time, including today, using graphs to describe situations. So then table 4, for part B, how far away was the dog from the post when the owner left on day 1? One and a half feet. Class, any questions about that? Now, what is that part of the graph called that we have to look at? The starting point, and if we use like our math vocab, that's called our starting point on our graph. Like what key feature of the graph is that called? The y-intercept. There, someone whisper it. Get out and proud, yes. So y-intercept usually tells you your starting point of that situation. So also when the time is 0, right? And that's when the owner left. So then table 5, for day 2, how far away was the dog from the post when the owner left? 1.5 feet. So day 2, at 0 seconds, yeah, it started the line at 1.5 feet. Now table 6, for day 3, how far was the dog from the post when the owner left? 1.5 feet as well. I think that was another stipulation yesterday for the graph. Questions on that? Okay, so then table 7, part C. The owner returned 160 seconds after he left. How far away was the dog from the post at that time on day 1? So look at your day 1 graph, find where 160 seconds would be, and see where it touches on that line. What would that distance be? Approximately. We'll come back to you, table 7. Table 8, for day 2, the owner returned 160 seconds after he left. How far away was the dog at that time on day 2? Okay, well, let's see. So on day 2, here's 160 seconds. See where it touches on the line? It touches here. What's that distance? So on day 2, it was 4 feet. That makes more sense. So also look at the day 2 graph. Notice like there was no change in the distance from the post here. Like that's why it's flat. There's no increase. There's no decrease. So what does that tell you about the dog? What was the dog doing at that time? Nothing. Was he moving around? He was not. Probably sitting, laying down. He was not walking around like he was almost the entire time in day 1. Or it looks like in day 3, when the owner returned, so like this like downhill slope, was the dog getting closer or farther from the post in day 3? Okay. So day 3, looking at how this graph like trends downward, would that mean that the dog is getting closer to the post or farther from the post? Closer, because the distance from the post is decreasing. So just knowing how to read it and interpret it. So table 7, day 1, 160 seconds after the owner left, he returned. How far away was the dog at that time? Approximately. About 3.8. So you have to estimate that one. It's not like exactly at a nice point, but here's the 160 seconds mark. See where it touches on the line. Look at your y-axis for reference. It's between the 3 and the 4, a little closer to the 4. So I think 3.8 is a good estimate. All right, now whoever spoke for your group, rotate one to the left. I didn't assign reporters initially, so whoever took initiative and spoke, you're exempt from this round. Table 1, for day 3, that question, how far was the dog 160 seconds after the owner left? Day 3. Okay, I agree, about 0.5 feet. Because look at 160 seconds on that one, look where it touches on the line. About 0.5, I would agree. All right, table 2, part D, for day 1. How many seconds passed before the dog reached the farthest point it could reach from the post? Or you could also tell me, how do I know where the dog was the farthest on these graphs? Like, if this is my distance from the post in feet, where would he be the farthest at? The highest point on the graph. So we also call the highest point on the graph your maximum, if you want to add that in. That's going to be a focus like later on. But yeah, we're essentially asking you what's the maximum. So that would be where the dog was the farthest. So table 3 for day 1, how far was the dog at the maximum? About 5 feet. All right, table 4 on day 2. How many seconds pass? Ooh, I messed that up. So 5 feet is where it's the highest, but the question was how many seconds pass. So how many seconds is it that passed at our highest point in sync? 50 seconds. Let me change that because it didn't ask the distance. It asked how many seconds. So that would be 50 seconds. All right, now question, Karen? If you can answer this one for me, then yes. So for day 2, how many seconds passed before the dog reached the farthest point from the post? Okay, that would be the distance that the dog is. About how many seconds is it there? 35. About 35. That's good. Yes, we go. All right, so about 35 seconds there. Now where was I? Table 5. For day 3, how many seconds passed before the dog reached the farthest point it could from the post? Maybe 5 seconds. It's right here. So whatever you estimate that to be, seconds wise. So if these are counting by 20, I think my first hour estimated it to be like 1 second. But well, however you want to estimate it. 5 seconds, I think would be fine. But just know, like we're talking about based on what it is on our x-axis. So I'll even average that. I'll give it 3 seconds, but it's around there. So questions on that activity? All right, knowing how to read a graph is a skill and interpret it in the real world situation. That's actually one of our learning targets. So we've already met that. So here's the next part. I'm going to ask table 6. Consider the statement. The dog was 2 feet away from the post after 80 seconds. Do you agree with that statement? All right, is that a confusing question? Like, I'm not being sarcastic at all. Like, is that confusing? What's confusing about it? Was anyone else confused by that question? Did it ask me for any particular day? For number 2? It didn't. It didn't say like for day 1 or day 2 or day 3. So you answer it however you interpret it. What do you think it's talking about? Do you think it's talking about all of them? If so, then tell me the answer for all of them. All right, and then same for number 3. What was the distance of the dog from the post 100 seconds after the owner left? Didn't specify. So you answer these next 2 questions however you interpret it to be talking about. I'll give you about a minute, talk about it over with your groups, and then we'll continue. Answer 2 and 3, however you interpret it to be asking about. For number 2, the dog was 2 feet away from the post after 80 seconds. Do you agree with that statement? Mm-hmm. Yes. And for which day are you referring to? All of the days, one of the days. Okay, so let's check that. So at 80 seconds, let's see if it was at 2 feet. Do you guys agree that that's 2 feet for day 1? Fast, yes, no. So not for day 1. Let's look at day 2. At 80 seconds, is this 2 feet where my mouse is at? No, that's 4 feet, so not for day 2. Now for day 3, 80 seconds. Here's where it touches on the line. Is that at 2 feet? Okay, so maybe adjust that answer like yes for day 3 specifically. Or depending on how you answered it, No for day 1. No for day 2. All right. Questions on that? All right. Table 7. What was the distance of the dog from the post 100 seconds after the owner left? Okay, so let's see. For day 1, 2.2. So 100 seconds after, yeah, I would say that's about 2.2. And it didn't specify for all of them. It didn't even specify for any specific one. So we could even just leave it at that. But for the others, if you did it for like day 2, it would have been 4 feet. For day 3, it would have been about like 1.2 feet or something like that. All right, but notice in that warm up, every time I had to ask you a question, I had to like specifically say for day 1, for day 2, for day 3. And each time I had to read you that entire question and reference which graph I'm talking about. That is like a big mouthful, and they don't necessarily ask you it like that on a test. And then even on the second and third question, it was hard to determine which graph it was even talking about. So you would have probably ended up answering for all of them, which it might have only been true for some of them. Now, to combat that, and that's what like the whole point of today's lesson is, if we use something called function notation. So you have that on your paper, this image. Feel free to take notes in that area. Here's like the main point of the lesson. They use f of t, so they have a t. I prefer f of x, if you want to write that in next to it, equals y. So f of x equals y. So the x is like in parentheses. The way that we read this is f of x. And it's a way to basically shorten everything I just asked you. And that's usually how they ask these things on the test, is in function notation. So the way that this works is the very first part, the part that's outside the parentheses, is like your name of the function. So like function f is what this one would be. X is always your what of a function? Input or output? Input. So your input always goes in the parentheses for function notation. And sometimes they just leave it at that. They'll say, find f of 60. So they'll mean, what they mean for that would be 60 seconds since the dog owner left. The output is what that's equal to, your y. So sometimes they don't give you what the input is, but they give you what the output is, and they ask you to find the input, and vice versa. So that shortens everything we just talked about. And you see that on your test. You have to answer questions in function notation. So questions on that. Okay, so we're going to practice that now with the same situation that we have going on. I have the charts here if you'd rather like not have to flip back and forth, but it might be easier to see on your paper. I don't know. But what we're going to do is fill out this table using function notation. So we're going to use function f for day 1, function g for day 2, and function h for day 3. Those will be like your names of the function. We'll do day 1 together, but we're going to write them in function notation. So you would have to figure out what your input is. That's what's on your x-axis. If you have a graph, that makes it easy. So what's going in the parentheses should be your time for this one. And it's usually time for your input anyway. So we'll do day 1 together. What's the name of the function for day 1?
G.
Sorry, what was that?
G.
So for day 1, it was actually f. So right here. But yeah, for day one, it was F that they chose. And then what needs to go in the parentheses if we're talking about distance from the post 60 seconds after the owner left? All right, what's my input? Table 8, can you tell me what my input is? Doesn't have to be the actual number, you can just tell me if it's distance or time. Okay, tell me this. Is input X or Y? Okay, thank you. I was talking too late, but you weren't here for that. So table 8 is input X or Y? It is X. What is graphed on my X-axis?
Seconds.
Time in seconds. So when it's asking me distance from the post 60 seconds after the owner left, what do I need to put in place of the X? 60, that's all. And that would be me asking you this same question, but in function notation. Instead of asking you that, I would say find F of 60. And it just shortens it. It's just a shorthand. What is the answer for what F of 60 is? So look at day one, 60 seconds is here. What's that distance? 4. So then even include what the output is. Here's my input, here's my output. At 60 seconds, the dog was 4 feet away. Questions, comments, concerns? Okay. So then, yes. So is someone after Benji? All right, go ahead. Table 1. So now let's rotate the reporter, or really anyone. I guess we're still kind of exploring now. So table 1. What is the name of the function that we're using for day 1? The name of the function for day 1. What letter do they want us to use for day 1? F, thank you. So then table 2, when the owner first left, how many seconds have gone by? So if the situation was the dog's distance in feet since the owner left, and I need to put something in for the input for the time in seconds, then what do I need to put? When the owner left, initially, what time frame is that in seconds? No, 160 would be when the owner returned. What about when the owner first left? 0, good. So then it would be 0 for the time. And then how far was the dog when the owner first left? 1.5. And that's it in function notation. We already answered these, maybe not the last one, like we already answered the first 2 already. Now it's just in function notation. All right, table 3. If I'm asking you distance from the post 150 seconds after the owner left, what letter do I use for the function for day 1? F, good. Table 4, what's going to be my input in this one? I'm asking you 150 seconds after the owner left. So the input is X, time in seconds. What needs to go in as my input here? I feel like I'm spoon feeding a child that doesn't want to eat. Like I don't know how to make this easier. What is X? An input or an output? An input, where we graph it on the X-axis. What's on the X-axis? Table 4. Time in seconds. So if I'm asking you to write this in function notation and it says distance from the post 150 seconds after the owner left, what needs to go in for the X? 150. So then table 5, what's going to be my output? At 150 seconds, how far is the dog away from the post? The dog? About 3.7. Because here's where 150 seconds is, like in the middle-ish, about 3.7, about 3.8. But that's how you do that. That's all I'm asking you to do. Okay, so now you guys in your groups figure out how to write in function notation for day 2 and day 3. And then we'll go a lot faster, hopefully, this next time around. I'll give you 2 minutes to figure out the rest. So for day 2 and day 3, you're writing it in function notation. So how would I ask distance from the post 60 seconds after the owner left in function notation for day 2? G. Okay, good. And then do we also have the output at that time? 4. Good. All right. And the way to formally read that is G of 60 equals 4. That means that 60 seconds after the owner left, the dog was 4 feet away from the post. And then I can tell you, like on my answer key, it just has it as G of 60 because that's like what it would ask you, find G of 60. We're including both for practice. So table 1, for the second row, day 2, how would I show in function notation that one? For when the distance from the post and the owner left. All right, you've got this. What's the function name? What letter do I use first? G. And what's my input in that one? And what's my output? 1.5. All right, so for day 2, we said we'd use function G. So it has to be G of 0. That would be when the owner first left, 1.5 feet away. Table 2, day 2, for the last one. What would you write? All right, so looks good, has the right input, has the right name. Let me just verify that that's where it is. And yes, it has the right output. Table 3 for day 3, what is it in function notation? That question. H of 60 equals 4. So yeah, function H for day 3, 60 is the input. Is that 4 feet away? Table 4, the next row, when the owner first left, how would you write that? Okay, perfect. And then table 5, the last one for day 3. All right, perfect. So let me just double check that one. 150. Yeah, that looks like about 1.5 there. Let me maybe move this over so you can actually see what the output is. But yeah, are we getting the gist of function notation now? It's just a shorthand way to ask you and answer things. So then let's look at these 2 now. So we just practice function notation. I think we're getting the hang of it. Now I want you to just talk about these in your groups. So what do these mean? What is it asking about? What graph would you look at? And then same for these ones down here. And they have an input or an output. All right, just talk about them briefly. We'll go over some of them. So like, what does it mean when it says F of 15? What is it asking you about? Talk about that with your groups. Give you like 2 minutes. Bonus if you could tell me what the answer is for them. Like, what is F of 15? What is G of 48? So as we go over these, I might not necessarily write down everything that you say, but that doesn't mean you can't. But F of 15, what is it asking about? I'll take a volunteer this time. So we can get this moving. Maybe you'll have time to do your practice today. So for day 1, and what about day 1? So we're trying to figure out at 15 seconds how far the dog would be. Does anyone know the answer for F of 15? Yeah, I would say a little over the 3. So yeah, something around there. So good. G of 48, what day is that referring to, class? Day 2, and in that one, it's wanting to know 48 seconds after the owner left about how far was the dog. Yeah, you have to estimate it. I would agree about like 3.6-ish, something like that. All right, so good. I think we're getting the hang of it. Now in C, so like H of T, it's talking about day 3, but this time they're not specifying what input. All right, they're just telling you the input's time. That's it. Now for these ones down here, and today we're just looking at graphs. Eventually you'll look at tables, at equations, and you'll have to solve for inputs and outputs in function notation. But for this set of them, let's look at B, this one, where it says F of T equals 5. So on this one, they're giving us the output. Can you figure out what the input is? First of all, what graph do I need to look at? It's F of T. We gotta look at day 1. And if I know my output is 5, and your outputs are always on the y-axis, see where the line touches. And see, because they don't know what T is, how many seconds is that about? About 50 seconds. So if you were told to solve for T, and you had a graph, you just have to look at the graph and see what's my input when the output is 5. For that, T is 50. Another great test question, because I do take your tests and see, like, is the math doable? Does it align to our curriculum? I always make sure. So we know the answers of these, and let me just double check because I feel like it was a little bit different here. Sorry, 1 second. Okay, no, it's good now. Maybe I was just wrong earlier. But a great test question would be something like this. So you know how to answer these individually, but say I asked you to solve this. G of 48 minus F of 15. All right, you know what these are individually. What I'm really asking you is to do 3.6 minus 3.2. And what is that value? 3.6 minus 3.2. 0.4. So don't get hung up on, oh my gosh, now it's really confusing. It's just as simple as it was when you did this. You just have to figure out, okay, well, what's the output for those? Do the math, and that's really it. That's going to be really similar to something on your unit test. So you have to be able to answer questions in function notation. All right, so I think that that's good. Got a lot of practice in. My first hour said that the homework was easy. So here's what we'll do. Anyone need this before I switch pages? All right. Instead of doing the entire cool down, let's just look at number 3, because number 3 is also similar to something that is on your unit test. So a baker sells dog treats, the number of dog treats X and the price of dollars Y of their packages are given in the ordered pairs below. The ordered pairs are also a function. So something we learned about yesterday. What makes this a function? None of the X's repeat. So the fact that none of the X's repeat, I don't even need to look at the Y's. I already know it's a function. If any of them did repeat and they had different Y's for the same X, then it would not be a function. All right, but now do this. The bakery is considering adding a new package of muffins. I feel like they meant dog treats, but whatever. Add 3 other combinations of dog treats and price to the ordered pairs above. And then after adding their combinations, does it still represent a function? So still try this. Add some combinations of dog treats and their prices in coordinate forms and be able to tell me if it's still a function or not. So we'll go over this, I'd say in about 4 minutes, which is way longer than you actually need. But that'll give everyone time to try it. If you try it and you are just waiting for us to go over it, please take out your Chromebook and start to practice. So 4.1 and 4.2, but this is the one for today. So answer this first, number 3 on your cool down, and then start working on the practice as well. Does anyone want to share what they put so we can see if it's right and if it's a function or not? You could have put pretty much anything you wanted. It's just that happens in your combinations. All right, so then let me ask you this. If I made my combinations look like this, and they didn't necessarily have to follow a pattern, sometimes there's not a pattern that you can distinguish and it's still a function, like all those day 1, day 2, day 3 graphs, those are all functions. If I chose these coordinates, would this still be a function? Raise your hand if you think yes, it's still a function. Raise your hand if you think no, it's not a function. Raise your hand if you still don't know what makes it a function or not. Okay, so that just tells me it's more of a I don't care versus an I don't know. All right, but what makes it still a function? The X's don't repeat at all. My X's are 1, 3, 5, 7, 9, 11, and 13. Not one says a repeat. I don't even need to look at the Y's in that case. So let me change this a bit. So when I change it to these coordinates, is it still a function? Yes, all I changed were the Y's. The X's still do not repeat. All right, what about if I change it to this? Is it still a function? All right, so what repeats then for the X? Now, when I see that an X repeats, look at the Y's for that. Are these Y's the same? So it actually still is a function. So that was kind of like a trick one. But say I change it to this instead. Is it a function now? Now it's not. Because now I have an X that repeats with 2 different Y's. That can never happen. All right, so that's basically the gist. That's the question that you'll be asked on your test. Is this a function? Does adding this coordinate make it a function? Blah, blah, blah. All right. But good, now continue using the rest of the time to work on both your practices. I have all the practices from Unit 4 available. I even have one of the study guides available for the Unit 4 test, like we're there. Do not fall behind now. If you currently have an F, you should be expecting a Saturday school invite from me. So be on the lookout for that. But if you happen to get your F up by Wednesday, like coming to tutoring and things like that, then you might not have to go on Saturday. Still recommend Saturday school for all of you.